Okay, so this is question 28 from 2022 set 2. So in this this is a, like a, not a straightforward question, like but this is actually a result in you can observe in this, like you can get it from the textbook. So it is a straightforward result, like suppose a flood control structure having an expected life of n years, okay, is designed by considering a flood of return period of t years. Okay, let's say when t equal to n, let's say here I mean to say that, let's say if you observe this particular point here, if you see here, when t equal to 110, corresponding to design life of n equal 100 years, how much value you observe? 60. Let's say when n equal to 100 and t equal to 96, how much we observe? 0 0.6. Okay, just keep these two values in mind. Let's say if t equal to n, and if t equal to n and n tends to infinity, okay, the structure's hydrologic risk of failure in percentage will be, okay. So can anybody guess how much will be the value? Maybe a approximate guess. I've given the hint from the previous table also. The value lies between 0.6 to 0.65 only. Okay, let's see how we can solve. Okay, so this we know, this I have shown you, risk equal to r equal to 1 minus q power n, q power n, q power n. See, this q power n is probability of non-occurrence of event in n years. Okay, our what is our risk? Our risk is what is the probability of at least once. Okay, so that's why we used 1 minus q power n. Okay, so q is nothing but 1 minus p. So I can mention here p plus q equal to 1. Okay, this is one basic equation from a probability. So let's say this is a favorable outcome, favorable probability, this is a non-favorable probability. So the favorable probability plus non-favorable probability always equal to the 1. It's a basic probability law. Okay, so now this is so q equal to 1 minus p. So we'll substitute here 1 minus p power n. So we know from earlier slides p equal to 1 by return period. Okay, 1 by return period. So substitute that 1 by t, 1 by t power n. Okay, so what they mentioned here in the question, given that t equal to n and n tends to infinity. Okay, what we do now, we'll just do some trick here. So what with that, we replace t with n. Okay, so it will be limit n tends to infinity 1 minus 1 by n whole power n. So okay, now what we do is that we'll take this minus inside and put the plus, because why I have performed this, that we have this result, we have this result from BTech for BTech mathematics. So when limit x tends to infinity, 1 plus x whole power 1 by x will give the value of e. So we will shuffle the terms such a way that we can get this particular value, e exponential value. Okay, that is our aim here. So what we are doing, so now 1 plus 1 minus will go inside, so 1 by n whole power n. So okay, now what we do is that let assume minus 1 by n equal to y. So n will be, so it can come down, so 1 minus y. Let's say when n equal to infinity, when n equal to infinity, what will be the 1 by infinity? It is 0. Okay, so that's why, like at n equal to infinity, y equal to 0. So these are the like few basic mathematics from BTech first year. So I hope you're comfortable with that. Now we'll just use the same analogy here. So limit n tends to infinity 1 minus 1 minus 1 by n whole power n. So it can be written as, maybe it will be confusing. In this is fine. Limit, then we'll substitute this n y in place of n. So limit n y tends to infinity 0, 1 plus y whole power minus 1 by n. So because we know that n y equal to minus 1 by n. Suppose if I do n equal to, it will be minus 1 by y. So that's why it is here minus 1 by y. Now so this is like this. So what even we can do, this minus we can take it out. Oh, maybe I made a mistake here. This is 0, not infinity. So now limit y tends to 0, 1 plus y whole power 1 by y. We can write it in this format. So this particular result will lead to e power minus 1 as from the previous slide. So limit x tends to, in place of x you imagine y, x tends to 0, 1 plus x whole power 1 by x equal to e. Okay. So this will give the value of this whole, inside the bracket will give the value of e and e power minus 1. Okay, this is r. So r equal to 1 minus e power e power minus 1. So it's nothing but r equal to 1 minus 1 by e. When you enter this particular 1 minus 1 by e in the calculator, you will get a value of 0.6321. But in the question, it asks to write it in a percentage. So it will be 63.2%. Okay. Is it clear? Uh,
Yes, sir.
Yes, sir.
okay. So this is a result you can remember always. When t equal to n, the risk will be equal to 63.2%. This is a standard result you can remember, because many times you may tend to forget this limit result. So maybe you can by heart this particular equation. When t equal to n, the result, the risk will be 63.2%. So this particular table is depicting the same as like